Hello, I'm Mr. Manley, and today we're going to talk about inverse functions. I'm going to begin with a simple application where we're finding an inverse function, and then I'm going to talk about things more conceptually to put inverse functions in perspective. So what's going on here is that we've got this function, we've got a function, and we want to find the inverse of that function. Something to note right in the beginning here is this is the notation for the inverse. So if I've got a function f, its inverse is f negative 1. It's not f to the negative 1. So don't think about this negative 1 as an exponent. It's a notation that means inverse in this context. And the way that I would read this is f negative 1 of x. Here we want to know what is f negative 1 of x given this f. It's a simple procedure that you may have seen before if you've taken Algebra 2, and it begins by substituting a y for f of x and then switching the x and the y. In this case, there's more than one x, and both of them I will change to y. And on some level, this is the meaning of inverse, it's switching x and y. And when we look at things conceptually with a graph and with some numbers, you'll understand what I mean by that. Now, from here, we are going to solve for y. So how am I going to solve for y? I'm going to cross multiply here to begin with. And then I'm going to isolate y. So I'm going to skip ahead a couple of steps here. Okay, so I skipped ahead a couple of steps, and if you need to read that, you can pause the video and make sure that you follow these two steps. But what I've done is I've isolated y, and just note that when there's more than one term that has a y, if you're trying to solve for y, you're going to end up factoring it. Factoring the y. Now, I'm just about finished here. Solving for y, I get negative 2x minus 4 over x minus 1. And that is the inverse. Now that I've followed this process, these steps here, so it was substitute y, and then switch x and y, and then it was solve for y, and now that's the inverse. So I'm going to use that expression to say what the inverse is. So the inverse f negative 1 of x is negative 2x minus 4 over x minus 1. And we found the inverse. Now, what does that mean? Let's go ahead and take a quick look at that, and then we'll talk about things from a conceptual perspective. Okay, so we're trying to figure out what does it mean that I have found the inverse. So here I have graphed the function f of x, and that's how I did that. That's a lesson for another time. But just trust me, this is the graph of this rational function, x minus 4 over x plus 2. And now here is the graph of its inverse. So I got the red function f, the blue function inverse, and see if you can you see the mirror image of these two? Specifically, if I took this line, so I've added the line y equals x. So there's the line y equals x. Can you see how the two graphs are mirroring each other through that line? So here I'm looking at this red piece on the bottom, and then that's mirrored through the line y equals x to this blue piece. And then I'm looking at this blue piece on the bottom, and I'm looking at how that's mirrored through the line y equals x. that's what it means to be inverse, or that is a meaning of what it means to be inverse. So let's take a look at how we arrive at that conceptual understanding and maybe get it tied in a little bit with the algebraic procedure that we just followed there. So here's a function that we don't know the equation for, right? So we're just given this function. Right here, this function graphed in black. And that is some function f of x. So I'm going to just call it f of x. I don't know anything about it. I mean, I could figure out and do a piecewise function, but I don't know precisely what the expression is for it. I just see it. I have it visually. So taking what I said back here, that a visual understanding of this is a reflection through the line y equals x, I'm going to use that here now. I'm going to try to use it here. And I'm just going to kind of estimate it, that if I have this function, now I've also already got my line y equals x, right? You can see that I've got the line, this is the line y equals x. So the reflection here is going to look like this. I'm going to take this up here. All right, so there I just took this piece and I reflected it across the line y equals x. All right. This is not necessarily something, by the way, that I would expect you to do, but you know, some people like to operate visually and some don't. So you don't have to do this. So here, now I'm going to extend that through, and now I want to take and essentially I want to mirror this piece here. So down at the bottom, can you see down at the bottom there? I want to mirror that piece through the line y equals x. So I'm going to extend this line up this way. All right? And then finally, it looks like I need this piece here. So the piece up in the upper left-hand side, I need to mirror that through the line y equals x. Like so. Right? So that's an understanding of inverse. What does it mean to be an inverse function? It's the mirror image of a function through the line y equals x. And that would, in this case, I say, okay, I've got f negative 1 of x. All right, so finally, let's look at this numerically, and that'll give us less of an estimate on the graph that I just did. So I'm going to take purple. So to do it numerically, so look over on the left here. On the left, I've got that table of values. I'm going to do that table of values for f of x. There's the table of values for f of x. Now, remember I said a meaning of inverse. So we have two meanings of inverse right now. One is here, the procedure that yields an algebraic expression. That's a meaning of inverse. Another meaning of inverse is here. Visually, we see it's a reflection of the equation, or the graph of the equation, through the line y equals x. And then finally, here, numerically, a meaning of inverse is that I am going to switch the x's and the y's. So I'm going to take all of these values here and say, okay, for its inverse, switch the x's and the y's. 4 and negative 2, 3, 0, 0, 1, negative 1, 3. You see how I just took the x and y values and I switched them. Now listen to what I said. Switch the x's and the y's. Now go back here. Remember when we first did this, what was the second step? Here, if you look on the left-hand side here, what was the second step? Switch the x and the y. So here I switched the x and the y algebraically. Here I actually switch the x and the y numerically. And then what that yields is, that's going to yield the graph that I kind of estimated here. If we plot these points, 4, negative 2, so 1, 2, 3, 4, negative 2, that would be, my graph is kind of off here, it looks like. So that would be down here, 4, negative 2, and then 3, 0 would be here. I had that point all right. 0, 1 would be here, and negative 1, 3 would be here. All right, and then if I drew that graph here, here, and then down there, I kind of got off track over here a little bit. Then I would have the actual better graphic representation by looking at it numerically and then graphically. Okay, so I hope you got that. and good luck.